Welcome again to a dashDB demonstration. Today we are going to look at dashDB's abilities to digest data in motion using dashDB's built-in Apache Spark and the Apache Spark Streaming API. The demo is specifically about digesting IoT device data streaming into dashDB. I will walk you through this IoT demo notebook that we distribute as part of a standard dashDB local Jupyter container. So first we simply open this notebook from the Jupyter start page of the dashDB Jupyter container. In this demo we are going to receive IoT device data from wind generators out in the field that is coming in via a Kafka infrastructure. We use a dashDB Jupyter notebook to create the Spark logic that receives and processes this data and lands it in dashDB tables. And then we bundle this all up in a Spark application that runs in the background inside dashDB. Before we can start, we first need to set up the demo data producer for the IoT data. As you can see here, it is also just a part of the standard distribution of a dashDB Jupyter container. All what you need to do is to run these three commands here in order to build, run and start the demo producer container on the same machine as dashDB in Jupyter. So after you have cloned the project on your machine for the Jupyter container, you just can enter the directory of the demo producer and run the docker build command. And we are fast forwarding a little bit here. It will take you about a minute until this build is done and your container is ready to get launched. So now we just run our demo data producer container, and then we can use a fourth optional command to verify and observe what kind of IoT messages are arriving in this Kafka topic here. So back to our notebook. Another setup step that we need to perform at least once for each user is to set up the Kafka assembly jar file in our dashDB system. There's just one cell that you need to run once per user, and then you can always use Kafka from that point on in your Spark logic in dashDB. Now we are importing a set of classes, for instance, to do the Spark streaming. And then we are setting up the configuration for our Kafka topic, as you can see it here. So the host name and port and the topic name in fact match our IoT demo data producer that we just set up a minute ago. Next, we define ourselves a little utility function that we can use to run different types of processing of the streaming data that we will use in the subsequent steps. So this utility function runs the provided processing function every 3 seconds, so it will batch up all the arriving IoT messages per 3 seconds time period. The utility function will also only run for a provided timeout period of milliseconds. For the notebook, we set it to 10 seconds. Note that we have flagged the cell as not for app, which means when we generate an application later on out of this notebook, this cell will not be executed in this background application, and instead we will use a default, which means the timeout is disabled. So now let's explore our streaming data a little bit. We first run utility function with a plain processing function that simply just takes the message and plots them out as is, so basically just the JSON body. So it will run for 10 seconds and plot out all the messages that it receives within this time period. Now we have an idea of the type of data, basically the schema of the messages, so we can now put this into a schema definition, as we can see it here, and then use that schema definition to really map it to a data frame. This is what we are now doing here in another processing function that we pass into our utility function, and this processing function then also just prints out the data frame in a tabular form. So this now gives us enough confidence to say, well, this is exactly what we would like to have in a real table in dashDB. So we now define a processing function that does exactly that. That takes a target table and uses our Spark dashDB data source in order to write the messages using the schema into this target table. Again, passing into the utility function. This will run for 10 seconds. Now each message coming in this 10 seconds is inserted into the physical table in dashDB. So now we can operationalize the whole thing. We use the built-in capability to deploy the notebook that we've created here right directly into a deployed Spark application in dashDB. Simply select File, Deploy as, Deploy to dashDB-Spark. This will translate the notebook into a Scala application, and it will skip all of those code cells that are flagged with not for app. This is also responsible for the fact that this background application does not have a timeout set, and it will run until you stop it, receiving all of the IoT messages permanently and writing it into dashDB table. When the generation and deployment is done, you can use one of the three options here to launch the deployed Spark application. But for your convenience, we have actually prepared for you notebook cells to do exactly that right out of the notebook. So in the notebook, we are using the Spark submit stop procedure that we call through a JDBC connection. And we do this with the asynchronous flag, which means we just get back a submission ID that we now remember. We also print it out so that we can later on use it again to stop this application right out of the notebook. While we keep this background application running, we can scroll down to the last section of the demo notebook where we find a simple way to verify the arriving data in the persistent table just using a standard data frame, and we simply can just run this one cell to plot out the summary of the table content a couple of times, and we can see, yes, the records are arriving in a permanent fashion. So with just these few clicks, we in fact have operationalized our stream processing application into dashDB itself. We can just keep it running, but for the sake of demo here, we can now finally also use the last cell that we haven't looked at that just takes a submission ID and stops the background application again. When we now look at the table content again, we will see even repeated executions of this one cell will show there's no new data arriving in this table. This ends our little demo. I hope you are as excited as me how easy, effective and self-service it now is to process, analyze and land streaming data right into dashDB.